Hey, AP PreCal, it is Miss Kosh. We are looking at section 2.1, change in arithmetic and geometric sequences, and we're going through Mr. Passwater's notes. So here we go. Okay, a sequence is a function from the whole numbers to the real numbers. Okay, so basically what's happening is you have a particular, we'll talk about the first term, the second term, the third term, the fourth term. Those are whole numbers and they get matched to any sort of value, any sort of real value. And to be honest with you, I don't know that it has to be real, but that's how AP PreCal defines it. This means we're only able to plug in whole numbers, 0, 1, 2, 3, into a sequence, but we can get any real number as the output. As a result, when we graph a sequence, we have points, but we cannot connect them to form a line or curve. Okay, so it's a discrete set of points. Okay, so consider this sequence defined by a sub n equals 4n minus 3. I would say a sub 1 is when I plug in 1. 4 times 1 minus 3 is equal to 1. A sub 7, 4 times 7, 28 minus 3 is 25, and there we go. Okay, in this course we will study two important types of sequence, arithmetic and geometric. It looks like arithmetic, but we say arithmetic. Okay, so arithmetic sequences, successive terms have a common difference or a constant rate of change. And these are the two formulas that AP PreCal likes to use. They'll say a sub n equals a sub 0 plus dn. This is not my first choice. I mean, this is how I like to end up my equations, but I don't usually start there. What I prefer is a sub n is equal to a sub 1 plus n minus 1 times d. That's my preference, but it's not the ones that I'm getting more in line. I'm starting to like what AP has required a little bit more, but it doesn't. I mean, ultimately, you just have to get to the right answer. So a sub 0 is the initial amount. This corresponds to the y-intercept of your line. D is your common difference, and a sub k is the value of the kth term. Arithmetic sequences behave like linear functions, except they are not continuous. Increasing arithmetic sequences increase equally each step. Slope always remains the same. Okay, so if it's going to be linear, if it's going to be arithmetic, you're adding the same amount each time. Okay, so for example, 3n plus 1. So when I plug in 1, I get 4. So 1, we'd have a point at 4. I plug in 2, I get 7. I plug in, well, this is kind of annoying. I plug in 3, and I'm, what is that, 9 but 10? So I'm up, anyway, it would be a line. So it would follow that line. It was just kind of steep and off the graph pretty quick. Okay, for each of the following, determine if the sequence could be arithmetic. If yes, determine the common difference. This one, as soon as I see a square, it's no longer linear, therefore it's not arithmetic. On this one, the common difference is negative 2. So if you want to see, you could plug in 1, we get 4, plug in 2, we get 2, plug in 3, we get 0, and we could keep going. The common difference is equal to negative 2. The common difference would be the slope of the line, and you could rewrite this to say negative 2n plus 6, and then you can see that slope a little more clearly. What are we doing here? I see that I'm adding 5, I'm adding 5, I'm adding 5, I'm adding 5. So yes, d equals 5. Now, something weird could happen in the sequence later, and it's not arithmetic, but based on what they told us, yes, it is. This one, we're subtracting 3, adding 6. Subtracting, well, what they're doing, they're oscillating between positives and negatives. And had it just been 1, 2, 3, 4, 5, that would be arithmetic. But 1, negative 2, 3, negative 4, 5, no, that's not arithmetic. Okay, let's see what is next. The next bit, let a sub n be an arithmetic sequence with a sub 3 equals 8 and d equals negative 3. Find an expression a sub n and use that expression to find a sub 12. Okay, here's where we can use a sub n is equal to a sub k plus, how do they write it? Do they do d times, I think they say d times n minus k, but I prefer n minus k times d. I just put the common difference at the back, whatever. A sub k, so what we're saying here, a sub n would be equal to a sub 3 plus n minus the 3, and then we know the common difference is negative 3. Okay, well, I plugged in some of it. A sub 3 is equal to 8, so this is 8 minus 3n plus 9, which a sub n would equal, I like to write it this way, plus 17. And so to find the 12th term, a sub n is equal to -3 times 12 plus 17. I think his notes are good, but go back and watch mine. I give a little bit more foundation for what a sequence is and how it works. And I think I'm not going to go into all the detail in this video, but if you go look at the video I made yesterday, my 2.1 and 2.2 videos on arithmetic, I think will be a little nicer to work with. Or it gives you a little more foundation. Okay, so then when I subtract that, what's that? Well, when I combine those, add those, is it -19? If I'm wrong, comment below. I just don't feel like thinking. Well, I can do the hard math. Sometimes I forget how to add. Okay, let a sub n be an arithmetic sequence, a sub 2, a sub 6. They give us values. Find the expression for a sub n and use that. Okay, so we know that a sub 6 would be equal to a sub 2 plus, well, 6 minus 2 times the common difference. So a sub 6, we can plug in 9. A sub 2, we can plug in 7, plus 4 times the common difference. Subtract, that gives me 2, divide that, so my d value is 1/2. Okay, so then I have a sub 6 would be equal to, what do I want to do? No, I wanted to do this. I need an expression for a sub n. A sub n could equal a sub 2 or a sub 6. So a sub 2 plus n minus 2 times d. Okay, a sub 2 is 7. N minus 2, our common difference we just found to be 1/2. Okay, and so then I have a sub n is equal to 1/2 n. This becomes a -1. So 6. 7 minus 1 is 6. My brain just saw that and automatically just said 6. Okay, and so now to find a sub 24, I have 1/2 24 plus 6. That's 12 plus 6 is 18. So the 24th term of this sequence would be equal to 18. So here were the two answers they were looking for. There we go. It was something like that. Okay, several terms of an arithmetic sequence a sub n are shown above. Okay, so what do I see? I see a sub 1 equals 6. I see a sub 2 equals 4. I see a sub 3 equals 2. And I see a sub 4 equals 0. Find an expression for a sub n and use that to find, okay. I see a common difference of -2. And actually, I see a sub 0 is equal to 8. I didn't even see it initially, but there it is. So a sub n could be equal to a sub 0 plus n times d, or d times n, I think is how they like to write it. I just always put d at the back. I don't know why. What is it about old dogs or new tricks? Okay, so this is 8 plus my common difference we said was -2. Well, n times -2. Okay, now that looks a little sloppy. A sub n is equal to -2n plus 8. Okay, so to find the 17th term, a sub 17, 2 times... What is that? -34 plus 8 would be -26. Am I right? If I subtract, that's 34. If I subtract 10, I'm at 24, but I didn't subtract 10, so I'm at -26. Okay. And there we go. Let's see. There is more. So that was arithmetic. I think we can keep going with this. Geometric. So with geometric sequences, successive terms have a common ratio or a constant proportional change. And so these are the two formulas that AP PreCal likes. The one that I like is G sub n is equal to G sub 1 times R to the n minus 1. Go watch my other videos because I do a better job of laying the foundation. G sub 0 is the initial value, R is the common ratio, and G sub k is the value of the kth term. Geometric sequences behave like exponential functions, except they are not continuous. Increasing geometric sequences increase by a larger amount each step. The percent increase always stays the same. So they start, well, increasing exponentially or decreasing exponentially. So on this one, if I plug in 1, I get 4. If I plug in 0, I get 8. And then I plug in 2, this gives me, well, I take 4 multiplied by half again, I'm at 2. Plug in 3, I'm at 1. Plug in 4, I'm at 1/2, and I just start kind of getting closer and closer, something like that. So I'd get a whole bunch, like the first term when I plug in 1 is 4, then it would be 2, then it'd be 1, then it'd be 1/2, then it's 1/4, then it's 1/8, and I can keep going forever and ever, and they're a little harder to graph, but there you go. Okay, for each of the following, determine if the sequence could be geometric. No, this is a quadratic. it doesn't, I'll have to ask the calculus teachers. I don't think that type of sequence, I mean, you could call it a quadratic sequence, and I have stuff I do in IB where we figure out how to find the sum of things like this, but it's kind of, this is beyond the scope of pre-cal. Okay, this one, we have so yes, this is geometric, and our R value is equal to 2. On this one, I added 2, I subtracted 1, I added 4, I subtracted 2. Are we multiplying? So that was weird. Let's see, if we multiply by 3, then we multiply by 3 halves. Then we multiply by 3, then we multiply by, not 3 halves, 2/3. And then we multiply by 2/3. And then we multiply, no, we can't, no. We have to multiply by the same thing the whole time. I might have said the wrong thing, but it's still no. Okay, this one, on this one I have half of 16 is 8, half of 8 is 4, half of 4 is 2, but then I say I'm going positive, negative, positive, negative. So yes, this is geometric, and our R value is equal to a negative 1/2. Okay, so on this one I see A of 0 or G of 0. I don't always, I'm more likely to default to calling any sequence A, but it's clever to use A for arithmetic and G for geometric, but I will often call geometric sequences A sub whatever, and it doesn't matter. Okay, so this was at 8, and then G sub 1 was at 4, and G sub 2 is at 2, and G sub 3 is at 1. This is the same one we just graphed. Yeah, okay. So find that expression, that G sub n, we had this equation. Oh, you can't see what I'm doing, I'm sorry. G sub n is equal to G sub 0 times R to the n. So this would be 8 times our R value is 1/2 to the n. So that was exactly what they did there. That was clever. Okay. Oh, look, this is part 2. Let's make that another video. So like, subscribe, comment, all the things, and as always, go practice.